Higher vorticity.
Yeah, what's that? Where's that bullseye right there? The northern one, where is that bullseye?
No, so you're talking this one?
Both of them. This, I'm sorry.
Oh,
I
yeah,
didn't
yeah,
explain
sorry.
what I'm saying.
Go ahead, yeah.
Yeah, this whole region here. Where is that? What city is it next to? On the left, you know that? Yeah. Wind speeds.
Starting to get a little bit of low-level rotation on this storm as well on the lowest tilt of Pueblo radar.
That tornado report's got to be spurious. But you were seeing Pueblo or Dodge City or Woodland? What? Maybe all three?
I see the flanking line now.
Go west on Highway 50 a bit and see if we can't intercept it along that highway. I don't like the idea of putting stuff north and south on a north-south arrangement on this cell.
Do you want to try deploying the PIPs along US Highway 50 between Syracuse and Holly then?
That's what I was trying to say a bit ago, that the angle it's going to be making with the north-south road is going to be too oblique. It's going to be moving directly towards us, so let's not, boy, it's got a beautiful structure on radar.
You know, this is the reason that we do it. This is the reason that we go storm chasing, is so that we get to witness nature's spectacle like this. It's really amazing to see this happen, and just to understand that the entire environment is supporting that phenomenon over there, and that we succeeded in making a forecast that allowed us to witness that.
The what? It's at 14 knots right. 2,
Start shooting.
1. All right. Average 13.4.
So the dry line did convect down in Oklahoma too, so that would have also been a potential. Nice contrast down in there. Look at that. There's a clear slot behind it. You can see sunbeams coming in behind it. Oh, that's so cool. So what we just witnessed was about a 15-minute end segment of a tornado that formed over by Tipton, Kansas, and had a very nice wide funnel for a long time, and then it developed into a truncated cone, and now it's dissipated apparently. So we're just keeping an eye on the same storm to see if it's going to wrap back up and produce another one. If it does, we'll be in perfect position to watch it. We just have to watch out for this nearer storm that's going to start raining on us.
See this whole area close ranks. That scud finger way on the right there, Robin, is that what I think it is?
It looks like a scud finger at the moment, but I'm keeping an eye on it.
Semi-persistent WX5 DTD.
Okay, it's just looking really filamenty.
So we collect data so that we can find out basically what environments these types of storms form in, and how we can predict them better. The reason that I try to use radars to scan storms is because we can get a lot of information about the precipitation environment that the storm is forming in, which controls how much evaporative cooling and latent heating is going on, and that's data that's very hard to come by otherwise. So what's in the cup is basically a miniature weather station, so it measures temperature, pressure, humidity, wind speed, and direction. And there's also a little radio transmitter, so it's transmitting data back to a receiving antenna that we have mounted on a computer inside the truck. So we can actually drive away and still keep receiving the data as the balloon is ascending. And that beeping sound that you're hearing in there, that's the actual data packets coming in. That's indicating that we are receiving.
We're having storms finally developing down south of Springfield, Colorado. We're here where this dot is, circle. In Tribune, Kansas, we just launched a balloon, which the data are coming in. I'll show that in a minute. A lot of other storm chasers out near Lamar, Colorado, in this area. This is the signs today point to potentially very volatile setup if storms can become discrete, that is, kind of by themselves and not agglomerating into a big blob. If they can stay discrete, then they can potentially produce tornadoes later on. But it looks like they may be trying they may form very quickly and what we call grow upscale into a larger system, which would become more of a damaging wind and hail threat. So we're kind of here, just keeping an eye on the storms that are forming to our southwest, moving this way. So right now we have a balloon that's in the air. It's at about 400 millibars, which is about 6 kilometers above the ground. This is showing the temperature drop with height. And after we reach that capping inversion, there's almost a straight drop with height of about 10 degrees Celsius per kilometer. We're collecting good data. It's collecting wind speed, direction, temperature, relative humidity. It's really high up there right now. It's about halfway up the troposphere. So that's the lowest layer of the ground, which is in the lowest 10 kilometers or so. It's about halfway up there. It's showing that the atmosphere is fairly unstable, which means that any storms that develop could be potentially pretty strong. Currently, there are storms developing to our southwest over Colorado, moving this way, that are showing signs of intensifying rapidly. But they're also not showing signs of becoming supercells yet. Supercell would be a rotating thunderstorm. So we're keeping an eye on things. We may have to move here like really quickly. So.
Yes, that's what I'm looking at, because look, there's a very clear RFD clear slot.
I see the clear slot, but
I'm starting to light it, and it looks like it may actually be, rotating.
It is rotating, but just look, the scud there, it's like barely rising there.
But it's rotating. It might be an optical illusion.
We need to get in better position. The storm is moving away.
I can almost guarantee you every parking spot between here and...
Every parking spot between here and Denver's right.
Yeah, probably. So when I look at a storm like this visually, hey!
What do you see?
Is that just outflow?
The wind just shifted, we're in outflow here.
Yep. So I just, I'm mentally superimposing radar observations on top of all of this stuff. I'm saying, okay, the reflectivity over in this area with the heavy precipitation core is going to be high. Back in the Hook echo, we're going to be able to see through the precipitation curtains. In the Hook, you'll see again a thickening of the precipitation curtains, and looking at the movement of different parts of the storm, I'm envisioning what the Doppler velocity field would look like. So we're just and then mapping all of what we see visually onto the radar data that we collect helps us to understand exactly what's going on, what the internal dynamics of the storm are, and what it's doing. We've got actually two separate storms right now that are interacting with each other. I don't know if it's going to be constructive or destructive. We've got we've got one storm off to the north that's producing buckets of precipitation, but it looks really stable. The base is really laminar, not very turbulent. But we're keeping an eye on it because it looks like that we are starting to get maybe a rear flank downdraft clear slot starting to form here. So let's keep an eye on this area. Way back to the southwest is our previous target storm, which is the tornado's long since dissipated, but we can still see the base. So we're just monitoring that to make sure that to see if it starts to develop new rotation on it, then we'll be ready to capture that on our cameras if we have to.
See that dirt swirl on the ground underneath the quad base rotation? No, it's still going. See the dirt there swirling? Under the quad base rotation? It's a tornado right now.
Well, my many years of graduate school training have taught me to just kind of swallow my emotions and mindfully enjoy the moment. Sometimes I have a job to do, and that's collecting data, and I don't get a chance to rewind and do it over again. So I have to be 100% focused on whatever my mission is. Today, since we don't have the radar with me, I was actually focused on collecting just some good storm video to share with the students and use as a teaching tool. If the radar had been here, we would have been scanning the storm the entire time that it was tornado warned, and we would have been able to hopefully see the evolution of the ZDR column inside the storm and how it changed as the tornado matured and then dissipated. So this is one of the reasons why we go out and collect the data. So personally though, like, I still get a big thrill out of seeing tornadoes. I still really enjoy just witnessing them, and I enjoy sharing that with my students and giving them a taste of that, being able to help them do that safely.
We get new updraft forming on the south, but this whole outflow is surging. I think we're done.